Hello everyone, let's solve some more polynomials. We're going to do some that are factorable, some where we need synthetic division, but at the end of the day, we're going to be able to find all of the zeros for these problems, which is something we haven't done yet. So for this problem, oftentimes we might look at it and just say, is this factorable? If you factor by grouping, and it actually is, so if I want to convert this into what we'll call intercept form, the factored form, I'll just factor it the old-fashioned way. I don't need synthetic division if it's factorable. So I have x plus 5 is one of my factors, x squared minus 4 is the other. Wait a minute, that's dots. So my zeros are my factors are x plus 2, x minus 2. And now if it says find the zeros or the x-intercepts, that would be at -5, -2, and +2. So if I have this guy and I graph it, I should see zeros at -5, -2, and +2. And I have the graph right here. You can see, hey look, we got it. -5, +2, -2. So we have all three x-intercepts. And that leads us to what is called the fundamental theorem of algebra. And that is, if you have a cubic, if you have degree 3, then there are 1, 2, 3 zeros. They are not necessarily x-intercepts. In this problem, we have 3 x-intercepts and 3 zeros. But there are 3 zeros, and you're going to see what I mean in a second, okay? So if you have an x cubed, you should have x equals 3 times at the end because there are 3 zeros. That's the fundamental theorem of algebra. If this is an x cubed, then I know there will be 3 zeros. So let's see, can I factor this x cubed plus 8? I could factor this, but I'm going to do what we've been doing with synthetic division. Because I think it's going to be what we need anyway. So if you say factor it, you know what? I might be able to factor it, I might not. Regardless, what I can do is I can graph it. And I can look at the graph in Desmos and I can see, wait a minute, there's only one x-intercept here. So what we're going to do is we're going to use the x-intercept that we know and we're going to synthetically divide to make this a quadratic. So I'm going to plug in -2 because that is a 0 and I know I'll get 0. I just have to be careful. The leading coefficient is 2. There's no x squared, there's no x to the first, and then it's 16. So you got some placeholder zeros. I better get 0, because it's a 0. Drop the 2. 2 times -2 is -4. Add -4. -2 times -4 is +8. Add. -2 times +8, -16. Hey, I got 0. Good. So I factored out an x plus 2, and now I'm left with 2x squared minus 4x plus 8. Now, the reason I know this is a degree 2 is because I started with degree 3 and I lowered it down. So that means this is x squared. That's what we've been talking about. That's the quotient. But what we also want to remember is if -2 is a 0, x plus 2 is a factor. So I'm trying to keep track of my factors. But now what I'm going to do is look at this quadratic and we're going to decide what's the deal here. Okay, -2 I see, but why aren't there any more x-intercepts? And what I'm going to do is I'll try and factor it, but I got a feeling this isn't going to work because, let's see, that's 4. If I factor out a 2, it's like what multiplies to 4 and adds to -2, and nothing does. So this isn't factorable. Guess what? That means we need to do the quadratic formula. So we're going to solve this quadratic using the quadratic formula. And if you remember, the first thing we always do is b squared minus 4ac, the discriminant. That's this part underneath the radical. So I'll use my calculator just to make sure I do this right, because it's very important we get this part right. -4 squared minus 4a, oop, that's not a c. So what's going on here? When I do the discriminant, -48, oh, they're imaginary zeros. The discriminant's negative, that means we have complex zeros, more precisely. So when I do the quadratic formula now, it's the opposite of b. The opposite of -4 is 4 plus or minus -48 over 2a. 2 times 2 is 4. And what we'll do now is we will say, okay, well that means that's 4 plus or minus I radical 48 over 4. And the last thing we'll do is we'll distribute that 1/4. This is 1/4. So 4 divided by 4 is 1. And then we'll just leave this as I radical 48 over 4. We haven't simplified radicals much yet, so we'll leave it like that. And then the third zero is, what do we say? -2. Okay. So we have 2 complex zeros and 1 real zero. And complex zeros don't show up in the graph. The only real zero is at -2. So if you sketch this without Desmos, it would look something like, I can do better than that. It looks just something like this. And what I want you to realize is that there is 1 real zero. There's only 1 real zero. There are 2 complex zeros. So we're going to use Desmos to get a zero, and we'll knock it down to a quadratic, which sometimes that means we might need to do it twice. And then we'll use maybe the quadratic formula. So these can be lengthy. Degree 4, all right. So this is going to have 4 zeros. Now I'm going to use Desmos and graph it, and I see that I have zeros at -5 and at +4. So let me start with -5. And what I'm going to do is synthetically divide. I know I'm going to get 0, 1, 1, -11, 9, -180. 1, multiply, -5, add. Multiply, add. -45, that's going to be -36. And then that's 50, or I'm sorry, 150 and 30, that's 180. Good, so I get 0. Now I was at degree 4, now I have a cubic. X cubed minus 4x squared plus 9x minus 36. Now, if you're working smarter, not harder, you might think, you know what, maybe I can just factor that by grouping. And you can, but I'm going to pretend like we don't notice that right now. And I'm going to say, you know what, I got a cubic, that's not a quadratic. I guess we got to go again. What zeros work for that? Well, look, we already knocked out the -5. The 4 is the other one. So when I plug in 4, I'm going to do 4 with this cubic, though. So I'm going to go down 1 more degree from a cubic using this. So 1, -4, 9, -36. Multiply, add. Multiply, add, multiply, 36. And you get x. This was cubic. Now it's x squared plus 0x. I'm not going to write that. Plus 9. Let's write what we got so far. X squared plus 9. I factored out x minus 4. That was one of my zeros. And the other was x, oh, what did I write 5? X minus 4. And the other one, I think, was -5. So that'd be x plus 5. Now, we have a degree 2, which means we could solve that. You could use the quadratic formula. You might not need to, though, because you can just solve this one with square roots. When does that equal 0? When x squared is -9. Square root both sides, and you get x equals plus or minus the square root of 9 is 3i. So plus or minus 3i, +4, and -5. We have 2 real zeros and 2 complex zeros. So we're combining some ideas from the previous unit into what we've talked about with the graphs, and now I can see there are only 2 real zeros, but there are 2 complex zeros. Okay, and that's what we got right here. Cool. Let's do one more. So we got x to the 4th plus 11x cubed minus 5x squared. All right, well, look, I see some zeros. I'm going to intentionally not mess with the 1. I'm going to do -10 first. So I'm going to start with -10. And now I will plug in 1, 11, 5, -47, and 30. So I'm using my graph to find a zero that works. And the first one I saw was -10. So I'm going to get 0. 1, -10, 1, -10, -5, +50, 3, -30, hey, good, I got 0. Now I have a cubic, 1x cubed plus 1x squared minus 5x plus 3. And I need to do it again, because this isn't factored by grouping. So, okay, I'll just do what I know how to do, which is find another 0. I use -10, now let's use -3. So we'll do another round of synthetic division with -3. 1, 1, -5, 3. I better get 0. 3, add. Multiply. Uh-oh, what did I do wrong? 1, 1, -5, 3. 1, 3, 4, 12, 7, 21. That's not 0. What did I do wrong? X cubed plus x squared minus 5x plus 3. Oh, it's -3. Duh. I got to plug in -3. Okay, look at the graph. It's -3 we're plugging in. All right. Try again. So when I plug this in, 1, 1, negative 5. Oh, that's why, because this was positive. I got distracted. 1, negative 3, negative 2. Positive 6, positive 1. Negative 3, good, 0. All right, so now I got x squared minus 2x plus 1, and then I'll write my other factors. If negative 3 is a 0, x plus 3 is a factor. If negative 10 is a 0, x plus 10 is a factor. But look, that is a quadratic. So you could use the quadratic formula, or maybe we can factor it. Does anything multiply to 1 and add to negative 2? Yes. Negative 1 and negative 1. That multiplies to 1 and adds to negative 2. So I have x minus 1, x minus 1, x plus 3, x plus 10. So we said if it's degree 4, there should be 4 zeros. You're like, well, okay, x equals 1, x equals 1, x equals negative. Wait, why did I list it twice? Okay, you don't have to list it twice, but this is an important idea. This is called a multiplicity of degree 2. And what you can see here in the graph is it bounces off the x-axis at 1, which means in our factored form, you could write this as x minus 1 squared. So this is like a double count. And every now and then you get one like that where it bounces off the x-axis, and that means it counts twice because there's that same factor is in there twice. So that's called a multiplicity. So even though I said there should be 4 zeros, there are 4. You just count that 1 twice. X equals 1 and x equals 1. That's called a multiplicity. So kind of tricky. Sometimes you get 4 real zeros, 1, 2, 3, 4. That's just a double count. Sometimes you get some real zeros and some imaginary zeros, and we saw one like that. But you will always have 2 complex zeros at a time. You'll never have an odd number of complex zeros. That's called a complex conjugate theorem. So we're going to do some practice problems. Make sure you smash that like and subscribe.